In various service industries, waiting time is crucial. There are two key concepts. 1. Target wait time. TWT. This is the target time for how long someone or something should wait before being attended to, or starting a task. 2. Service level. This is the probability that customers will wait equal to or less than the target wait time. Higher service levels lead to happier customers. There are two important points to note. First, the fraction of customers who wait less than the target wait time. Second, the fraction of customers who wait longer than the target wait time. In the UK, a well-known target is that at least 95% of patients should be admitted, transferred, or discharged within 4 hours of arrival at an emergency department. This target aims to ensure prompt care. Consider a call center, like Deutsche Bundesbank. In this scenario, 30% of customers wait longer than the target wait time of 10 seconds. The goal is to serve 80% of all customers within 20 seconds. The analysis also provides an approximation of the service levels. For example, the target wait time is set to 3 times TQ. The probability that a customer waits for 3 times TQ is 95%. To do this, replace TWT with 3TQ. In this setting, the call center achieved a service level where 90% of calls had to wait no more than 25 seconds. At the heart of our call center lies a constant challenge: understanding customer demand. Each day unfolds with its own unique rhythm as the number of incoming calls fluctuates. It's vital for us to manage our staffing levels carefully. This is to ensure we can handle these changes efficiently and provide top-notch service. As we observe customer call patterns, we notice distinct peaks and troughs throughout the day. To tackle this, we collect data every 15 minutes, allowing us to pinpoint exactly when demand is highest. This granular view helps us see not just trends, but also the unexpected changes that can catch us off guard. A key part of our analysis involves distinguishing between seasonality and variability. Seasonality refers to the predictable trends. For example, busier times of the year due to holidays or promotions. On the other hand, variability captures those sudden spikes or drops in call volume that can happen due to unforeseen circumstances. With this understanding, we take the next steps in creating a robust staffing plan. First, we time slot our data, breaking it down into specific 15-minute intervals. This allows us to estimate the expected call volume for each time slot, using parameters like the average call volume, average processing time, and the coefficient of variation. We can determine how many staff members we need at any given time. It's not just about understanding how many calls are coming in. We also need to make strategic choices about how to balance our resources. Finally, we choose the right number of staff, or M, to meet the requirements for each time slot. We also consider constraints like the maximum and minimum number of employees we can have on duty, and the necessary breaks for our team. By following this carefully crafted approach, we can successfully create a staffing plan that adapts to customer demand, ensuring we always have the right number of staff available during peak times. Pooling resources can lead to significant advantages. Imagine you have 2 independent resources, represented by 2 square shapes. Each one is a resource that functions separately. When we combine these resources, we get pooled resources. In this case, pooling means we group the 2 independent resources together. This combined resource is more efficient. Independent resources work alone and do not share. Pooled resources work together. They create a more powerful and efficient outcome. Pooling allows for better use of resources. It's an example of economies of scale. When resources operate independently, waiting time increases as demand rises. If demand is low, waiting time is manageable. As demand exceeds capacity, the waiting time increases sharply. In a pooled system, resources are shared among various demands. This sharing allows for flexibility and efficiency, rather than each resource working alone and potentially becoming overwhelmed. Pooled resources collaborate to meet needs. This leads to a smoother flow of service and more balanced utilization. Another remarkable outcome of pooling is the increased capacity to handle demand. When the capacity factor is reduced by half, it can lead to more than a 50% drop in average waiting time. This means that clients or customers spend less time waiting for service, which enhances their experience. As more resources are pooled together, the average waiting time for the process decreases. This is shown in the graph. When just one resource is used, m equals 1, the waiting time is very high. But as you add more resources, such as 2, 3, or 5, the waiting time drops significantly. Let's look at two systems: pooled and separate queue systems. In a pooled system, all customers share resources. Imagine there are 6 customers. Here, all servers are busy helping customers, and only 2 customers are waiting in line. In the separate queue system, we still have 6 customers. However, in this setup, each server operates independently. While 2 servers are actively serving customers, the other 2 servers are just sitting idle. This means 4 customers are left waiting. The separate queue system is less efficient. Customers can be waiting while some servers do nothing. This does not make the best use of resources. Pooling involves some challenges that workers and customers may face. Pooling may require workers to have a wider range of skills. This often means they need more training. For example, consider a call center that takes orders for both McDonald's and Wendy's. These workers need to be familiar with 2 menus. Another example is in healthcare. Cardiac surgeons usually focus only on heart surgeries. If pooling happens, they might need to learn skills for kidney transplants as well. This need for new skills can put pressure on both the workers and the training programs. Pooling can impact customer service. Patients often prefer to see the same doctor every time. With pooling, this may not always be possible. They could end up seeing different physicians, leading to inconsistent care. In queue management, pooling can affect wait times for customers. If one line serves multiple types of customers, it may lead to longer waits for some. For instance, if priority screening for first-class passengers is removed, the average wait time for all passengers might decrease. However, this will likely make the wait longer for first-class customers. In waiting time systems, we manage how services are delivered. This helps ensure that everyone gets what they need in a timely manner. On the left, 4 customers, A, B, C, D, are served on a first-come, first-served basis. Observe that the total wait time is 51 minutes. On the right, the 4 customers are now rearranged based on their respective service times. In this case, it starts with the customer that has the shortest service time and ends with that of the longest. Observe that the total wait time is 37 minutes. A critical rule in this system is called shortest processing time. This approach focuses on reducing waiting times by helping customers with simpler, quicker needs. By prioritizing those who require less time, the system can operate more smoothly and efficiently, reducing the chances of long wait times. However, when services are highly utilized, it can lead to longer waits for others. Therefore, it's vital to balance effective service delivery while maintaining high utilization levels. Another important aspect is understanding true prioritization. Recognizing the genuine order of importance helps avoid confusion in serving customers, and ensures that those who need assistance most urgently are addressed promptly. One of the simplest and most commonly used approaches is first come, first served. This method is straightforward and promotes fairness. As customers are assisted in the order they arrive, it ensures that everyone is treated equally, which is important for maintaining trust in the system. In addition to first come, first served, service sequence is crucial. Customers are prioritized based on the urgency of their needs. For example, emergency cases are addressed right away to ensure critical situations are handled promptly. This prioritization not only improves overall efficiency, but also helps those in desperate need receive the help they require without delay. Furthermore, the system often establishes varying service levels for different types of customers. This means that while some may require quick assistance, others may need a more extended interaction. By recognizing these differences, the waiting time system can cater to everyone's needs more effectively. Implementing these priority rules can greatly improve service efficiency. By focusing on the right order and urgency, waiting times can be minimized for everyone. In the world of managing waiting systems, understanding variability is crucial. Variability is not a rare occurrence. It is a common part of everyday operations. Because of this variability, waiting times often increase, even if the system is running at less than full capacity. To tackle this challenge, we can use the waiting time formula. This formula is a useful tool that helps us gain insights into how long people will wait. It allows us to analyze specific situations and provides recommendations to improve the experience for everyone involved. Managers play a significant role in addressing variability. It's essential for them to recognize where this variability comes from. By identifying its sources, they can take steps to eliminate or reduce it, making the system smoother for everyone. Additionally, maintaining flexible capacity is vital to accommodate fluctuations in demand. It's also important to distinguish between variability and seasonality. Variability can change day to day, while seasonality involves patterns that occur at expected times, such as during holidays or specific events. To manage seasonality effectively, we need to prepare for these anticipated changes in demand well in advance. Some important points to note. 1. Relevance of waiting time. It's not just about how long people wait. It deeply affects customer satisfaction. 2. Quality of service. A shorter wait usually leads to a better experience. 3. Challenges for managers. Managing waiting times is not always straightforward. Many factors come into play, and they aren't always easy to predict. 4. Inevitability of variability. Variability can lead to longer wait times, even if we don't utilize resources at full capacity. 3 factors influencing system performance. 1. Capacity factor shows the relationship between arrivals and the ability to serve them. 2. Utilization factor indicates how effectively resources are being used. It ranges from 0 to 1, where 1 means full utilization without spare capacity. 3. Variability factor incorporates different influences in the system. In managing waiting systems, it's essential to recognize the influence of various factors on wait times. One of the key components is the arrival of specific cases and how they are processed. By understanding these factors, we can determine the appropriate levels of capacity needed to meet demand. This involves balancing how resources are utilized with the goal of minimizing excess waiting time. Ultimately, achieving an efficient waiting system requires careful consideration of these elements. When we grasp the dynamics at play, we can make informed decisions that lead to smoother operations and improved service delivery. If you enjoyed this content, please consider liking and subscribing. Thank you.